Hey guys, welcome to part two of the four-part series of Walter Russell experiments. Please, if you're finding this video part two, please go back and watch part one first, because there's a little introduction so that you guys kind of know what's going on. Obviously, once you watch that introduction to part one, then you can watch part two, part three, and part four. Okay, guys, so here we go with part two of Walter Russell's experiments. And there we go.
Okay, so on number 4 here on page 132, he basically is describing make a coil in the shape of two cones. Okay?
Right.
And then that's what I have here. And then he tells you on page 133, he said, if you are not sufficiently convinced by this experiment, make two conical coils and put apices, both apices together. And then he says, spread the cones apart and put iron filings in there, and you will find that they will gather together in a ball. See that?
Yep.
And your needle will point always in the direction of increasing density in that ball. And then he says, pull the cones far apart enough to elongate your sphere into a spheroid. So we did that.
Right.
And then you can now use two needles for you have divided gravity. So you can either compress it into one center of gravity, or you can expand the center of gravity.
Right.
And we saw two versions of that.
Right. Yeah, I thought that was interesting, and I wondered about that. How something could have a center of gravity, but then if it's oblate like that, would that mean there are like two centers of gravity, if you will, like rotating around each other? Or
well, it's just essentially the one center starts to spread out, and that's why the planets start to kind of wobble, because it divides the center of gravity and it's not one point anymore.
Right.
So it's not a stable sphere. It starts to actually, the center equator starts to expand and the poles start to contract, and so it divides the center of gravity. But so this was, I lifted this experiment literally right off the page.
Off of the page of the atomic suicide.
And he tells you exactly how to do it. The only missing information maybe is, basic knowledge of how a solenoid works. It's basically proportional to the number of turns and the amperes.
Okay.
So it was the ampere turns that produces the strength of the field.
Right.
But that's not really necessary for this, because we're actually increasing the strength of the field just by the geometry of the core.
That's amazing. Yeah.
And that's what he's trying to teach us.
Right. And that's the main difference. Like, we always think of solenoids as just like a cylindrical,
Same
shape,
area on both ends of the magnet.
Right. Where this is purposefully different. One is a larger side and one is a much smaller side.
So we'll show that Walter drew in 1954 this very same experiment. He said, make a magnet like nature in the shape of a cone, right?
Right.
And so when we energize this coil, okay, we're gonna make one end of it magnetic.
Right.
Strong, right?
Yep.
And then if I kill the power, okay?
Right. Yeah.
So now we'll repeat it and we'll use the other end, base. You still
All right.
good?
Yep. We're good.
All right, so it's energized now. And see, it's only sticking on the outer edge.
Wow. Yeah. Just like in the picture.
Exactly like in the picture. And then here, I'll turn the power off. Boom.
Boom.
So it's not a permanent magnet. It's only magnetized when the current flows through the coil.
Right.
Just like a solenoid. But one end is contracted and one end is expanded. So I've applied an optical photo principle to an electromagnet.
Right.
So is electromagnetic theory
really even necessary.
really even a real
it can
thing.
be generalized into optics.
It could be a branch of optics and nothing more.
Wow. And gravity as well.
Gravity and magnetism are now unified in one understanding.
One force, one understanding.
Yeah.
So
you don't need four, what do they say, four fundamental forces?
Yeah. Like
gravity, electromagnetic, strong and weak nuclear.
Yeah.
Well, you definitely don't need strong and weak nuclear.
Right.
Because the atom's not. Look, if the atom was positively charged protons, right?
Yeah.
They invented the strong nuclear force to overcome the repulsion of two positive charges.
Right. Right.
And they said, well, there must be some force that's pulling the atoms that close, the atomic nucleus particles that close together.
Right.
But you can see with this experiment, we only create density through compression from the outside to the inside.
Right.
So there's no force gluing them together, like Walter said.
Right. Right. And that's the exact. They had to. When their theory didn't match with nature, they had to say, oh well, maybe there's some new force, right?
Yeah, they just invented
They just
force.
invented it. But in this case, this theory, it matches with nature perfectly, and we don't need those extraneous forces to explain things because it's already explained in a concise, comprehensive way on all scales.
Yeah,
It's great.
So they never teach you in school about, lopsided magnetics, or in other words, contracted North Pole and expanded South Pole.
Right.
But Walter tells us, and it's the only documentation I've ever seen where, he says you can pick up a nail. Actually, let me see if I can find a nail or something.
So if you like this kind of content, please like and subscribe. It really helps out the channel. All right, guys, that's it, and I'll see you in the next one.